Hi, welcome to the video for Edexcel Physics Past Paper Solution. This is Physics Unit 1, January 2018. So let's start. Question number 1. The unit of power is watt. Which of the following is equivalent to the watt? So again, it is all about SI drive and SI base unit. So watt is drive unit. SI drive unit, you need to figure out SI base unit. So power is energy upon time, that becomes joule second inverse, which is watt. So you can say that watt is joule second inverse and joule is Newton meter, because joule is the unit of work and work is force into distance. So force into distance, and Newton is kg meter second minus 2. This is mass, this is acceleration. So mass into acceleration is force, which is Newton, and another meter and s minus 1. So you can see that kg meter square s minus 3. So option is D. Question number 2. The thickness of a steel sheet is reduced by passing it between two rollers. Movement of the steel sheet, the rollers, the thickness reduces because the steel is ductile, hard, malleable, stiff. So you can see that the steel sheet is being compressed, so it is undergoing a compression. It can bear a lot of amount of compressional stress, and that means this is the property of malleable material. So the steel sheet is malleable. Option is C. Question number 3. Measured quantities can be either vector or scalars. Select the row from the table that is not correct. Okay, so measurement, this column shows the measurement and the vector. So the option A is 21 degrees centigrade. That is measurement of temperature, and of course it is a scalar quantity. So this is correct. We need to select which is not correct. So the option A is correct. 1/22, it is time, which is a scalar quantity. This is also fine. And minus 6.5 meters second minus 2. So this is velocity. Why it is velocity? Because the minus is showing the direction. So it's all about velocity, which is a vector quantity. So it is also a correct relation. And the last one is 15 joule, which is energy, or you can say it is work, and it is vector written here, but energy is not a vector, it is a scalar quantity. So your option in the table which is not correct is option D. Question number 4. A projectile is launched at an angle theta to the horizontal and takes a time t to reach its maximum height. Which of the following equations could be used to determine the initial velocity u of the projectile? Okay, so projectile is launched at an angle theta to the horizontal and time t reach the maximum height. If you see, you launched a projectile with some velocity u, making an angle of theta with the horizontal, and then the projectile moves like that, reaches at some maximum height. And you know that we have a two component. The vertical one is u sine theta, and the horizontal one is u cos theta. because they are talking about which of the following equation could be used to determine the initial velocity u of the projectile, and the projectile is reaching at a maximum height. So maximum height is all about vertical motion. So in vertical motion, we look at only vertical component, which involves sine. That means option A and option B are immediately gone. We need to select between C and D. Clearly, it cannot be the option D, because throughout the motion, you know that the acceleration remains minus 9.81 throughout, and it acts downward throughout the motion. But velocity, if the particle is moving up, the velocity is considered positive. When the particle or the projectile is coming down, the velocity is considered as negative. If you see the option D, due to this minus, the velocity is negative, and G is also a negative value. That means the option D is suggesting that U and acceleration has the same direction. But in fact, when it is moving up, acceleration is downward and velocity is upward. So they must have opposite direction. So your option must be C, as U is positive, which is showing upward direction, and G, when you use this equation, G will you will take minus 9.8. So they will have opposite direction. So your option is C. Question number 5. The flow of a fluid through a pipe is laminar. Which of the following statements correctly describe the velocity of the fluid? Laminar flow. Laminar flow is in any channel or in any canal. If you have laminar flow, so laminar flow is the flow in which fluid flow in a parallel layer. They don't mix, something like this. And okay, so at a particular position the velocity is constant. Yes, it should be the option. But let's discuss about B, C, and D. So at a particular position, the velocity is continuously changing. Velocity cannot continue. If the velocity is changing, then it cannot be laminar. It must be a turbulent. So B cannot be option because of this these situation. The velocity is maximum at the edge of the pipe. No, it cannot be your option, because at the edge of the pipe, because of the friction, these layer, the top and the bottom one, has a low velocity because of the friction. The velocity is always the same in adjacent layer. No, the adjacent layer cannot have a same velocity. They must have a different velocity. So if you consider that this is the topmost layer, this is the layer up below, and then so on, so the topmost layer has a highest or the greatest velocity. So adjacent layers has a different velocity. That's why D cannot be your option. So B, D, and C cannot be your option. But in fact, in laminar, at a given position like this, you can say that at this position the velocity is constant, and after this point there might be some abrupt change. But at that moment, the laminar, we have a laminar flow. So option is A. Question number 6. A solid cylinder of a diameter 0.025 meter is placed on a table. A force is applied to the cylinder as shown. This is the table. Cylinder 15 Newton. The stress in the cylinder in Pascal can be calculated using these options. Okay, so stress, if I use just a sigma, just a symbol, stress, so stress is force per unit area, and this force is a 15 Newton, and area is pi r square. So this area is pi r square. And if you see in your in the question, we are given the diameter. So in terms of diameter, the same formula, instead of pi r square, you can say that the area of cross section is pi d square by 4. So you can say that your stress is 15, which is force, divided by area pi d square by 4, and this 4 goes up and multiply with the 15. So 15 times 4 divided by pi d square. So if you see, 15 cannot be your option, cannot be, of course. So 15 times 4 pi 0.254 square, this is the diameter. Question number 7. A box of mass m is pulled along a floor by a horizontal rope. The tension in the rope is T. The box moves from rest with an average acceleration A. Direction of motion, this is T. M. Which of the following is the correct expression for the frictional force F acting on the box? So that means the surface is rough. Object is moving rightward, there must be friction leftward. And as it is accelerating rightward, that means T is greater than the frictional force. So you can say that T minus F must be your net force, due to which you have acceleration and the box is moving. And you can write now T minus F equal to ma. And if you rearrange this equation for F, so F is equal to T minus ma. B. Your option is B. Question number 8 and 9 refers to information below. A student carried out an experiment to determine the Young modulus of material in the form of wire. The original length and the diameter of a wire were measured. A load was applied to the wire and the corresponding extended length was measured. Which of the following combination of the original length and the diameter would produce the greatest extension for a given load? So you need to find which of the following combination of original length and the diameter would produce the greatest extension. So you need to find the factor on which extension depends. So if you see, the Young modulus says stress over strain. That means F upon A, force per unit area, it is a stress upon a strain, which is delta L over L, extension per unit length. And if you simplify these fraction over fraction, so you can have or you will have FL divided by A delta L. So Young modulus is also equal to FL A delta L, and you can make this delta L as a subject, so you can say that delta L is equal to FL over A Y. You need to relate original length and the diameter with the extension. So clearly you can say that extension is directly proportional to the length for a given amount of stress, and also delta L is inversely proportional to the area. So if length is longer, or the larger the length, larger the extension. longer the length, large the extension. So your option is the length should be long, so it cannot be C and D. Both are long. But what about the relation with the area? Or you can say the diameter or the area, same thing. So inversely proportional. So smaller the area, larger the extension. Smaller the diameter, larger the extension. So your option is B for question number 8. Question number 9. A student carried out an experiment, young modulus, okay, fine. The diameter of the wire was measured using a micrometer found to be 0.35 millimeter. This is the measured diameter. The micrometer reads the nearest 0.01 millimeter. That means this is your precision or the least count. Which of the following is the most appropriate percentage uncertainty to use this measurement? So percentage uncertainty, the percentage uncertainty we found by dividing the uncertainty with the observed value and multiply by 100. So the uncertainty in this case is the least count. So you will say that 0.01 divided by 0.35. If you divide these two, you will have answer around 0.028571, and you round it off and then multiply by 100 after rounding these off. So you can say that it is 0.03 times of 100, and then it is 3%. So your option is C. Question number 10. A mass is fixed to one end of a meter rule which is pivoted at the other end. The mass and the meter rule are held horizontally and then released. As shown in the first diagram, the mass moves to its final position as shown in the second diagram. Okay, this mass is released and it moves down, reaches at the minimum, or you can say the maximum depth, and then keeps moving up and reaches the final position. Which of the following is a graph of gravitational potential energy of the mass against vertical displacement for the motion of the mass? So you can see that as the mass is coming down, that means height is decreasing. If height is decreasing, so gravitational potential energy should decrease as it is coming down. This is first thing, meaning you cannot have option A, because in this graph gravitational potential energy is increasing with the displacement, and you cannot have option C. Again, the gravitational potential energy is also increasing first. So gravitational potential energy is increasing. Yes, as height is decreasing, the gravitational potential energy is decreasing. Once it reaches there, so gravitational potential energy becomes 0. Okay, and then as it is keeps moving, so gravitational potential energy starts increasing again. So it seems that the option should be D, but D cannot be the option because they are talking about the change in gravitational potential energy with respect to the displacement, not the distance. And remember, displacement is the shortest distance between 2 points, and between these 2 points and during the motion, displacement covered by the particle is the vertical displacement is this. So at a maximum height, it doesn't matter it is at the left or the right. This is the maximum height or zero displacement, and as it is coming down from left or from the right, displacement is increasing and the gravitational potential energy is increasing. So this is the maximum displacement, and you can see that the on option B, displacement is increasing, gravitational potential is decreasing, reaches at that point, and this point correspond to this. So your option is B. Thank you very much. Have a nice time. See you in the next part.